Namaste sabko, welcome to our channel. Today we'll be going to discuss the problem number 8 from the ISI MSTAT PSB 2023. The problem goes by this. Let x1, x2, xn be independent and identically distributed Bernoulli theta random variables where theta belongs to 0, 1. An unbiased estimator of theta is the sample mean xn bar. However, a statistician feels that the sample size n is too small and declares to increase the sample size. In order to do so, he records the observed values of the data points x1, x2, xn and then selects a random sample of size m equal to kn with replacement x1 to xn where k is a positive integer. The values in the observed sample are recorded as y1, y2, ym. The statistician proposes a new estimator t equal to half ym bar plus xn bar, where ym bar is the sample mean of y1, y2, ym. So we need to find that whether t is a better estimator of theta than xn bar and also that t is unbiased for theta. So for solving this problem, we need some key concepts of Umvue and Levin-Schiffe theorem and regarding the concept of empirical CDF. So, what is the Levin-Schiffe theorem? Let fx theta belongs to omega be the family of distribution of x. Let t star be a complete sufficient statistic for the family fx theta belongs to omega. Again, if expectation of h of t star equal to psi theta, then the Umvue of psi theta is the unique unbiased estimator h t star, and this is given by the Levin-Schiffe theorem. Now here we find out what is expectation of t. So expectation of t is nothing but expectation of ym bar plus expectation of xn bar by 2, and we know that expectation of xn bar is theta. So we have put it here. And now this is the concept of empirical CDF, which is fn of x1, x2, xn is summation I equal to 1 to n indicator function of I of xi less than equal to x by n. Now expectation of ym bar, we can write it as expectation of ym bar given x1 to xn. Now ym bar is nothing but summation I j equal to 1 to kn yj divided by kn. Okay, and we know that y follows empirical CDF distribution fn. And thus expectation of j equal to 1 to n 1 by kn expectation of yj given x1 to xn. So yj belongs to the distribution from x1 to xn, and thus the population mean is equivalent to the sample mean. So expectation of yj is xn bar. Since x1 to xn is a random sample, so the sample mean of it will be equivalent to the population mean of y, and thus expectation of yj given x1 to xn is xn bar, and thus we have got as expectation of xn bar equal to theta, and thus expectation of t is theta, which implies that t is unbiased for theta. Now for the second part, we'll use the Levin-Schiffe theorem. Now using Levin-Schiffe theorem, we can write expectation of xn bar given t star equal to xn bar is Umvue for theta. Also note that expectation of xn bar given t star equal to xn bar is xn bar itself because it is given, and thus it is a constant and expectation will not take place. And thus expectation of xn bar is Umvue, right? Using the Levin-Schiffe theorem. And thus it has now the least variance, and thus variance of xn bar is less than equal to variance of t. And thus t is not a better estimator than xn bar regarding the variance. Hare Krishna.